So this is what you're looking for. You'll count the number of, you want to take over here, or you want me to count the number of
Okay,
modules?
you're gonna be counting the number of modules, and basically with the cut sheet or with an actual module, you're going to be seeing the VOC. Typically, I mean, you'll see VOC ratings of 37.4 all the way to 64.9. So you're going to count the number of these modules, and you're going to multiply it by the VOC of say this was 37.4. Okay? So we don't want to exceed 600 volts ever. So you're gonna calculate that up, whatever that number comes up to, then you're gonna go to Article 690.7. There's a table at 690.7. That table is kind of a generic table, but it's gonna be for, I mean, I'm sure there's people here from all over the state. So you're gonna go with, we talked about a little bit earlier about your lowest ambient temperature ever recorded in that area. That is going to be your correction factor that's going to be in table 690.7. Now, there is a more accurate way, and sometimes designers will do it that way. You're going to be using temperature coefficients. And on the cut sheet, you're still going to use the lowest ambient temperature of the area that you're in, but you're going to use the information from the standard test conditions off those temperature coefficients. It's a more accurate way, and it'll actually kind of bring down that total VOC less than what what table 690.7. A lot of guys will just go ahead and use table 690.7, and that's a good way to do it, but it never can exceed 600 volts. So then you're going to see probably out of these, you're going to see some free air type PV type wire. And I don't know, this looks like it's a combiner box here, but typically they'll have a junction box on the roof, and then they'll switch over to EMT. Okay, that's where you're going to start sizing for the number of conductors, depending on how many strings they've got here, that they're going to come into that conduit. So you're going to have in Article 310, there's a number of tables for your ambient temperature reductions. Okay, you're going to be using 310.15b3c, 310.15b2a, and I think b2c. For the area, always remember, for the area that you're in, you got to find out that ambient temperature of the highest ambient temperature. Now we're talking high ambient temperature here, we're not talking about the lowest, because the lowest only affects the module itself. Now we're talking about high ambient temperature. So you're going to do those conditions of use to determine this size of conductor here. Now 690.8, they changed it in 2011 where they give you two options, and you have to go with the one that's worst case scenario. You can go 125% times 125% to figure out the size of these conductors. If not, that isn't the worst case scenario, then your conditions of use, which you're going to have to do a number of other calculations. They should have all of that done for you